Hey guys, welcome. Yeah, so in this video I'm going to show you a really cool proof of the sum of the squares of the integers formula, yeah? Okay, this is what I'm talking about. If you don't know, you should know that like 1 squared plus 2 squared plus on and on to some n squared, right, is equal to n times 2n plus 1 times n plus 1 all divided by 6. Now, for example, 1 squared plus 2 squared plus 3 squared will equal, well, in this case, n is 3, the terminating integer squared, that's right. Okay, so that would be 3 times 2 times 3 plus 1 is 7 times 3 plus 1 is 4 all over 6. Now 3 times 4 makes 12, divided by 6 is 2, so we get 2 times 7, which is 14. Okay, so this is easy enough to check because we can manually add. 1 squared is 1, plus 2 squared is 4, plus 3 squared is 9. 1 and 9 make 10, plus 4 is 14. Match. Ah, cool. So just prove the formula. No, I didn't prove the formula. I just showed in one example that it works. So how do we prove the formula? Well, the most typical proof of this formula is one that uses induction. That's the traditional proof. And in fact, I have a video showing you how to prove this formula using mathematical induction. But I want to show you a really neat, cool proof here. And here goes. Okay. Now, to start, notice that k plus 1 squared, rather, cubed, minus k cubed is equal to, well, it's equal to, what is it going to be? It's going to be 3k squared plus 3k plus 1, right? Just, you know, multiply k plus 1 by itself 3 times and subtract k cubed from it, you should get that. And you should know how to deal with binomials to an n power, so you could use that, Pascal's triangle, whatever you want. But this is true. Yeah? Okay, so if we start with k equals 1, so if we begin with k equals 1, then what we have is 1 plus 1 cubed, so that's 2 cubed, minus k is 1, so minus 1 cubed is equal to 3 times 1 squared plus 3 times 1 plus 1. That's when k is equal to 1. What about when k is equal to 2? When k is equal to 2, we're going to get 2 plus 1 cubed, so 3 cubed minus 2 cubed is equal to 3 times 2 squared plus 3 times 2 plus 1. On and on and on. 2, well, when k is n. When k is n, we're going to get n plus 1 cubed, right, minus n cubed is equal to 3 times n squared plus 3 times n plus 1. Yeah? Cool. All right, now let's add this up. So when we add on the left side of all the equal signs, look at what's going to happen. We're going to get positive 2 cubed, but negative 2 cubed right there. And then we have positive 3 cubed here. We're going to have negative 3 cubed right here. And on and on and on. So this minus n cubed here, we'll have a positive n cubed that will cancel it there. So everything will cancel, and the only survivors are n plus 1 cubed, and then minus 1 cubed right there, which is just minus 1. But what's the right-hand side? The right-hand side is 3, right? 3 is in all of them, times the sum from k equals 1 to n of k squared, right? This here is a sum of this first column. And then the sum of the next column is going to be 3 times the sum from 1 to n of the integers, and that's n times n plus 1 all over 2. I show you in two different ways that the sum from 1 to n of the positive integers is n times n plus 1 over 2. So yeah, that's this here, and of course there's a 3 in all of them, so times 3. And then of course we've got 1, not counting that's the first line, sorry, our k equals 1 line starts here, in case anyone is confused. But yeah, we have 1 plus 1 plus all the way to this one, and that's n ones, and so that just makes plus n. Yeah? Okay, cool. How convenient. Because now, using this equation, we can solve for this here, right? This parenthesis here. And then we will have found a proof of, well, we would have found a formula like this. And so then we proved the sum of the squares formula in a different way. Now, okay, so what should we do next? Well, what is this here? The left-hand side, n plus 1 cubed minus n is n cubed plus 3n squared plus 3n, and then it would have been plus 1, but there's this minus 1. So this here with the minus 1 is just this, and this equals, on the right hand side we have 3 times k equals 1 to n of k squared, right? And then k. And then plus 3 times, well, let's do this. It's 3 times n plus 1, so that's, and it's divided by 2, but yeah, that's 3n squared, right? 3n squared plus 3n, all divided by 2. And then we have this plus n at the end. That plus n, I'm going to take out of these 3 n's, which is subtract an n from both sides of this last equation, so I could write a 2n right here. Got it. And then next, if I multiply both sides of this equal sign by 2, then I'll be able to get rid of that denominator of 2. So I'm going to get, if I do that, 2n cubed plus 6n squared plus 4n is equal to, and then it's 3 times k equals 1 to n of k squared, and then it's plus 3n squared plus 3n. Okay, and clearly next I'm going to subtract 3n from both sides, which means that this 3n is gone, and this is now not 4n but just n. And then next subtract 3n squared from both sides, and so this is gone, and this 6n squared turns into a 3n squared. Got it. And then next, I'm going to factor out an n from the left side and write n times 2n squared plus 3n plus 1. But this here, 2n squared plus 3n plus 1, is just 2n plus 1 times n plus 1. So this equals this here. And so what do I have left to do? Well, I have left to do is when I multiplied by 2 on both sides, in this line I forgot to write, instead of a 3, a 6 here. So what I have left to do, right, pay attention. So what I have left to do is divide both sides of this equation by 6, and that way I will have simply on the right side 1 squared plus 2 squared plus ... plus n squared. And so that's what I intended to show, and yeah, okay, keep watching, take care.